Math 76, Lesson 31, Areas of Rectangles and Comparing Differences. So, quick recap when it comes to rectangles. I'm going to go ahead and use a ruler so I can draw this as neatly as I can. Let's go ahead and draw let's draw a 4-inch by, make it 2-inch rectangle. So, quick recap, we've already learned about perimeters of rectangles, and now we're going to be learning about areas. So if you remember, perimeter is quickly summed up as the distance around a shape, and the area we would call the distance inside of the shape, or the area inside of the shape. So, what I've just drawn here is a 2-inch by 4-inch rectangle. Now, to recap on perimeter, the way we'd find perimeter is we'd add up the length of all the outsides, right? So if we wanted to find the perimeter of this rectangle, we would know that this side would also be 4, this side would also be 2, because the opposite sides are equal in a rectangle. And then perimeter would just be 4 plus 2 plus 4 plus 2, which comes out to 6, 10, 12. So the perimeter of this rectangle would equal 12 inches. All right, and we'd just write our answer like that. Now, in order to find area, we have to understand the concept of what units we're using. So, when we're looking for the area of a rectangle in inches, what we want to find out is how many 1-inch by 1-inch squares will fit inside of this figure. So if I draw a 1-inch square right here in blue, it's going to be, hopefully this will be a really good square. Maybe I won't draw any of these lines crooked, and hopefully my square won't be crooked. All right, but this is the type of unit that we're looking for, right? And this is what we care about in area. So right here we have a 1-inch by 1-inch square, right? Perimeter is pretty simple because, like I showed you with the ruler on that video, we're just taking the ruler and we're rotating it around the shape to figure out how long the distance is around the shape. Right, and if I do that, I end up with 12 inches. Now, for area, we want to figure out how many of these squares will fit inside of this rectangle. How many of these 1-inch by 1-inch squares? So we've got two options. One, we could draw a bunch of these 1-inch squares inside the rectangle and see how they all fit. Or we could multiply. And so really quick, to find the area of this shape, what we do is we take the length of 4, we'd multiply it by the width of 2. Or you could say we could take the base of 4 and multiply it by the height of 2, and that would give us the total number of squares that'll fit. So what we do is we would take 4 inches times 2 inches. 4 times 2 would give us 8, and then inches times inches would end up being inches squared. And we'll learn more about those exponents, but pretty much this equals 1 square inch, or inch squared, right? So when we say 12 inches, we're talking about 12 1-inch lines, right? If we're talking about square inches, we're talking about these boxes. So your label is very important on area. It's very important that whenever you're doing area, you make sure that your unit is squared. Now you can write 1 inch squared like this, or you can write 1 square inches. Right now the preference is up to you, but eventually we'll learn about exponents and then you'll only be writing them this way. So the question is, how many of these will fit in here? And we can do that quickly by multiplication. Now, let's put some logic behind this, though. So I'm going to go ahead and mark off this square for every single inch mark. So on the bottom line, I'm going to have 1 tick mark right there, 1 tick mark right there, there, and there. All right, so that's 1 inch, 2 inch, 3 inch, 4 inch, okay? I'm going to go ahead and do the same thing on the width side. And I've got 1 tick mark right there. Okay, so now we've got 1, 2 inches. Or if you prefer, the base and the height, which is actually my preference. I like to call this the base, I like to call this the height. It's a little more uniform for me. So in order to figure out these squares, all we have to do now is extend these lines, right? So I can take this 2, we can extend this line all the way across, and I know that I've cut this into 2 rectangles that both have a height of 1 inch. So 1 inch, 1 inch. Right? And then I can take this line right here and I can extend this one as well. It's kind of like a crooked line. Whoops. We'll pretend that line is straight. Oh no, another crooked line. Oh well, I guess it'll be all right. Okay, so pretending that all these lines are perfectly straight, we now have perfect 1-inch squares whenever we cut a shape up like this. So that gives us 1, 2, 3, 4, 5, 6, 7, 8 1-inch squares. All right, so that's what is happening in multiplication. You're taking these 2 rows and multiplying by these 4 columns. One way to think of it is that I've got a block of 2, 1, 2, 3, 4 times. So I can either add 2 4 times, or I can multiply by 4. Or you could say I've got 2 rows of 4 2 times, so 4 and 4. So I can either add 4 and 4 or multiply by 2. So whenever you think of area, you have to think of multiplication. Area is closely related to multiplication. So now that we understand that, let's go ahead and do a couple practice problems. Let's say I have a rectangle here. And, oh wow, man, that doesn't look nearly as good as that one. Okay, we'll make do. So let's say that this side is 5 feet, not to scale, and we'll say that this side is 11 feet. To find the area of this rectangle, I would take 5 feet times 11 feet, and that would give me 55 feet squared, or I could write 55 square feet. All right, and that's all it is for finding area of rectangles. Also, the same goes for finding the area of a square, because technically a square is a regular rectangle. So let's say we've got a really nice square here, and it's got a side of 4 and a side of 4, and we'll say this is centimeters. All right, so all I would do is I'd take the base of 4, multiply it by the height of 4. 4 centimeters times 4 centimeters, that would give me 16 centimeters squared, or I could write 16 square centimeters. All right. That's it for finding area of rectangles. Now let's talk about comparing differences. When they say comparing differences, they're more or less talking about the distance between numbers, or figuring out which number is farther away or closer to another number. Let's see here. I'll find a good example for us. Yeah, 64. Okay. If you look at example 3 on page 155 of your textbook, in example number 3, they ask you which one of these numbers is closest to the number 64. So they give you A, B, and C. They've got these 3 numbers, and they want to know which one is closest to 64. Right? So that's the number that we're trying to figure this out. There's 2 ways we can do this. We can either just use simple subtraction, or we can do this logically with a number line. So I'll go ahead and draw a number line, and this number line will not be to scale, and that's okay. So I've got 0, and then somewhere far down the number line, I have the number 64. In order to figure out which number is closest to 64, all I have to do is mark the other numbers on here. So I can just take my pen and I can mark up to 71. So 64. So then I've got 65, 66, 67, 68, 69, 70, 71. I'll extend my line a little bit more. All right, so 71 is over here, right? And that is 1, 2, 3, 4, 5, 6, 7 units away from 64. And then I can count down to get to these other 2 numbers. So I'll count down. I got 63, 62, 61, 60, 59, 58. Oh, 58 is one of them. So 58 is right there. And then I've got 57 and 56. 56 is right here. So I can already tell 56 is not going to be the right answer, because 58 is already closer to 64. But what's closer, 58 or 71? Let's count the spaces. Let's see here. We've got 1, 2, 3, 4, 5, 6 spaces to 58. And then I've got 1, 2, 3, 4, 5, 6, 7 spaces to 71. So the closest number to 64 is in fact 58. So for my answer, I'm going to go ahead and write C, number 58, and that will be my final answer. Now, that's the number line method. The fastest method of doing this is to simply use subtraction, because remember, they're asking differences. So what I would do is every number that's bigger than 64, I'd subtract 64 from that number, and then any number that's lower than 64, I'd subtract those numbers from 64. So if I'm going to use algorithms, what that looks like is this. I take 71 minus 64. I regroup that 7. 11 minus 4 is 7. 6 minus 6 is 0. Okay, so I know the distance for 71 is 7. Distance is 7, which we see here on the line. And then for the smaller numbers, I would take 64 and I would subtract those numbers. So I take 64 minus 58. Regroup the 6. 14 minus 8 gives me 6, and so then the distance for 58 is 6, which is what we saw over here. And then if I really wanted to, I could double check 56 just to make sure. 64 minus 56, regroup that 6 into a 5. 14 minus 6 gives me 8. 5 minus 5 is 0, and 8. So the distance from 64 to 56 is 8. The shortest distance would be 58, which gives me the same answer. That's it for this lesson. If you guys have any questions, let me know on the school website, and I will see you in class.